While many might assume all wire ropes are created equal, Halo rope distinguishes itself through its engineered performance. Unlike standard wire rope, it boasts a proprietary construction, often incorporating specialized core materials and strand configurations. This results in a superior strength-to-weight ratio, enhanced flexibility, and improved fatigue resistance, akin to the difference between a high-performance engine and a standard vehicle. Fabricating a sling of this magnitude demands precision and expertise due to the immense forces involved. The process begins with meticulous material selection, emphasizing high-tensile strength wire and Halo rope's unique core, whether it's a fiber core or an independent wire rope core, IWRC. Next, the wires are laid into strands, and the strands are precisely laid around the core, with the lay pattern, wire count per strand, and strand count carefully chosen to optimize performance. For a 3-inch sling, socketing or heavy-duty splicing is crucial. Socketing, involving molten zinc or resin to secure the rope end in a steel socket, is often preferred for its high-strength capabilities. A 3-inch Halo rope sling is designed for the most demanding applications, including heavy construction, offshore oil rigs, and shipyards, where lifting massive loads with unwavering confidence is paramount. Safety is paramount when handling such loads, making the reliability and performance of Halo rope indispensable. Traditional cable splicing is time-consuming, a significant issue in field operations where time equals money. Dakota Riggers addresses this with a system that emphasizes efficiency without sacrificing the crucial strength of the splice. The swagging or crimping process, where the connector/sleeve is attached to the cable, is performed using calibrated hydraulic tools. Dakota Riggers may also use go-no-go gauges for quick verification of the swage. Furthermore, they've streamlined the inspection process, potentially using visual indicators on connectors or sleeves for rapid verification of proper connections, and employing portable testing equipment for on-site strength verification. Their modular system, featuring pre-made cable and connector sections, enables rapid on-site assembly, facilitating quick repairs and replacements, and minimizing downtime. It's crucial to emphasize that quick does not equate to sloppy in Dakota Riggers' methodology. They adhere to strict quality control standards, recognizing the potentially catastrophic consequences of a faulty cable splice. Texcan is a well-known manufacturer and distributor of high-quality wire and cable, supplying industries such as construction, telecommunications, energy, and automation. Their manufacturing process is carefully controlled to ensure that each product meets the highest industry standards for durability, safety, and performance. The process involves several key steps, from raw material selection to final packaging and distribution. The first step in Texcan's manufacturing process is selecting high-quality raw materials. Conductors, typically made of copper or aluminum, serve as the pathway for electrical signals or power transmission. Copper is preferred for its excellent conductivity, while aluminum is used for its lightweight and cost-effective properties. The insulation materials which protect the conductors include PVC, polyvinyl chloride, XLPE, cross-linked polyethylene, and EPR, ethylene propylene rubber. Some cables also require shielding or armoring, such as aluminum foil, copper braiding, or steel wire armor, to protect against electromagnetic interference or mechanical damage. The outer jacket, made from polyethylene, PVC, or rubber compounds, provides additional protection against environmental factors like heat, moisture, and chemicals. Once the raw materials are selected, the next step is wire drawing, where large diameter copper or aluminum rods are reduced to the desired thickness. This is done by pulling the metal rod through a series of progressively smaller dies, which stretch and thin the wire while maintaining its conductivity. This process ensures that the wire meets the required electrical properties before it is wound onto spools for further processing. After the wire drawing process, the wire is often too hard and brittle for practical use, so it undergoes annealing to restore its flexibility. This is done by heating the wire in a controlled furnace to a specific temperature and then slowly cooling it down. The result is a more ductile wire that can bend and twist without breaking, making it suitable for various electrical applications. In many applications, multiple thin wires are twisted together to form a stranded conductor, which is much more flexible than a single solid wire. Texcan uses stranding machines to twist the individual wire strands into different configurations, such as concentric stranding, compact stranding, or rope stranding. This process improves the wire's flexibility and durability, making it easier to install and use. The next step is applying insulation to each conductor to prevent electrical leakage and protect against environmental hazards. The conductor is passed through an extrusion machine, where melted insulation material is evenly coated around the wire. After extrusion, the insulated wire is cooled using a water bath or air cooling system to solidify the insulation. Once cooled, each wire undergoes a high-voltage test to check for any faults or weak spots in the insulation. Certain types of wires and cables require additional shielding or mechanical reinforcement. Shielding is done using aluminum foil, copper braiding, or conductive polymer layers, which help block electromagnetic interference, EMI. For industrial and underground cables, a layer of steel wire armor, SWA, or aluminum armor, is added to protect against mechanical impact, ensuring that the cable can withstand tough environmental conditions. Once the shielding and armoring are complete, the final outer jacket is applied to protect the cable from heat, moisture, chemicals, and abrasion. The cable is passed through another extrusion machine, where a protective plastic or rubber compound is evenly applied. The jacketed cable is then cooled and printed with product specifications, voltage ratings, and manufacturer details for easy identification. Before the cables are approved for use, they undergo strict quality testing to ensure they meet safety and performance standards. Electrical testing is conducted to measure conductor resistance, insulation integrity, and high voltage endurance. Mechanical testing assesses the cable's tensile strength, flexibility, and impact resistance, while flame resistance testing ensures compliance with fire safety regulations. Texcan ensures that all cables meet industry certifications such as CSA, UL, IEC, and NEC before they are distributed to customers. Once testing and certification are complete, the cables are prepared for packaging and distribution. Depending on size and length, cables are either spooled onto reels, coiled, or placed onto wooden drums. Protective wrapping is applied to prevent moisture or environmental damage during storage and transportation. Each package is labeled with product details, batch numbers, and test reports, ensuring full traceability and compliance with quality standards. Texcan's wire and cable manufacturing process follows a highly controlled and precise series of steps to produce reliable, high-performance products. From raw material selection, wire drawing, and stranding, to insulation, shielding, and jacketing, every stage is carefully monitored to meet the highest safety and durability standards. With advanced manufacturing technology and strict quality control, Texcan continues to be a trusted supplier of premium wire and cable solutions across multiple industries. Lifting Products is known for its meticulous approach to manufacturing, particularly when creating swaged wire rope slings using the Flemish eye splice. This method, renowned for its strength and reliability, involves a detailed process to ensure the final product meets stringent quality and safety standards. The process begins with the selection of high-quality, inspected wire rope, followed by precise measurements to determine the required length for both the sling and the eye. The rope is then marked to guide the subsequent splicing procedure. The next stage involves carefully separating the individual strands of the wire rope, a task that demands skill to maintain the integrity of each strand. The core of the wire rope is either removed or manipulated, depending on the rope's construction. These separated strands are then bent back to form the eye, with careful attention paid to achieving the correct shape and size. The strands are interwoven or flemished back into the body of the rope, creating a robust mechanical interlock that is a hallmark of this splicing method. A metal sleeve, typically steel or aluminum, is then placed over the spliced area, and Lifting Products uses a hydraulic press to swage or compress the sleeve. This process forms a permanent and secure connection. Swaging is a critical step, requiring precise pressure and the use of appropriate dies to ensure proper compression. Following this, each sling undergoes a thorough visual inspection to identify any potential damage or defects. Proof testing is conducted to verify the sling's working load limit, WLL, and dimensional checks are performed to ensure compliance with specifications. Finally, each sling is tagged with its WLL, serial number, and other essential information, and certification documents are provided to confirm its quality and adherence to industry standards. By combining the strength of the Flemish eye splice with a meticulous swaging process, Lifting Products produces wire rope slings that are not only strong, but also durable and reliable, providing essential confidence in heavy lifting operations. Hardanger Maritime Center, located in the beautiful Hardanger Fjord region of Norway, is a center for the preservation and development of traditional Viking shipbuilding and rope-making techniques. The center is not only a popular tourist destination, but also a place to preserve and teach valuable knowledge about maritime crafts. One of their special products is 4-strand tarred hemp rope, a durable, traditionally crafted rope that was important in classical maritime trade. Tarred hemp rope is an indispensable part of traditional maritime trade, thanks to its high tensile strength and ability to withstand heavy loads. The tar acts as a protective layer, preventing the rope from being damaged by seawater or humid environments. The production of rope at Hardanger Maritime Center is a meticulous process that requires skill and patience. The main raw material is hemp, which is grown and harvested from selected areas. The hemp fibers are separated from the stalk and processed to remove impurities, ensuring the fibers are clean and long. The hemp fibers are straightened and combed to ensure they are parallel and untangled. The fibers are then twisted into small bundles, forming the main yarn. To increase strength, each bundle is compressed and adjusted in length, ensuring uniformity. Natural tar is heated to become flexible and easy to adhere to the fibers. The hemp fibers are dipped or coated with tar evenly on the surface. This process not only protects the rope from moisture, but also helps the rope maintain a stable shape for long-term use. After impregnation, the rope is dried in controlled environmental conditions. The hemp bundles are fed into a spinning machine to form long, even single fibers. This process can be done by hand or by machine, depending on the scale of production. 2 single fibers are twisted together to form a double yarn. This twisting process adds strength to the rope. 4 double strands are twisted together in a certain direction to form a quadruple rope. This twisting process gives the rope high strength and good tensile strength. Each completed coil of rope is rigorously tested for tensile strength, bitumen adhesion, and water resistance. Only products that meet the highest standards are shipped. In addition to manufacturing rope, the Hardanger Maritime Center also plays an important role in preserving traditional maritime techniques through exhibitions, training, and education.